Hey guys, this is Yusan. In this video, I'm going to talk about problem 7 from the DSP1. So in this question, we're going to match the pole zero diagram with the frequency response diagram. So we start from the first one. We could say that the first one, we have two complex poles. So, complex zeros. So we're gonna have resonant diagram. So we could just say the angle, which is around pi over 4, which means that we're gonna arrive the peak at around pi over 4. So let's check the frequency diagram. Since this one, we could say that this one apparently just show half of the whole diagram. So this is one peak is around pi over 4. So the first one matches with the first one frequency diagram. So let's try the diagram 2 and 4. We could just compile those diagrams together. So in this diagram, we could try to find the function. This is a real number. It's around, minus 0.9. So I just tried. So this one is this. It's just a round number. So when omega equal to pi, so this one is equal to -1. This one -1. So this whole the final results is 10. It's a large number. The diagram 4, we could say that the real number it's around 0.9. So we have this. So when omega equal to pi, this one is equal to -1. This one equal to -1. Minus 0.9. So this one, it's a smaller one. It's around, since they only have one zero, so they have only one peak. So apparently only 2, 4, 3 have one peak. 2, 4, 5. So since for diagram 2, the result at omega equal to pi is a large number, so at omega equal to pi, it's a large number. It's 10. It's correct. And for diagram 4, when omega equal to pi, it's a small number. It's around 0.5. It's definitely this one. So the diagram 2 matches with diagram 4. The diagram 4 matches with diagram 2. So next we're going to look at the diagram 3. So we could see this one. It has two zeros, which are complex number. So we have this function. Since it has two poles, two zeros, so we get this one. We could say that when omega is equal to plus minus pi, this one equal to 1, this one equal to 1, so the whole result is a 1 over 2. When omega equal to 0, this one equal to 1, 1 plus 1 equal to 1 over 2. So we could say that it's gonna have resonant peak, and the start at the end, the result of start at end will be 1 over 2. So it's apparently this one, because when omega equal to 0, it comes close to 1 over 2. When omega equal to pi comes to 1 over 2. So let's try to figure out the diagram 6. Because for this one, we could say that we have two zeros, two poles, so I try to find the equation like this one. When omega, you could say that when omega equal to pi over 4, this part is equal to 0. So try to find out that. So this one matches with diagram 3 because we could say that around the pi over 4, the diagram comes close to 0. And it has a resonant peak apparently, so so this one matches with diagram 3. Let's look at the diagram 5. We could say that we have 3 zeros. 2 of them are complex numbers and 1 of them are real numbers. So we could say that around the angle around the pi over 4, the frequency will come close to peak, and when the frequency, the omega equal to 0, it still comes to peak. So we can see that, which is this one. It comes to peak at pi equal to 0 and pi another peak at pi over 4.